Today we are going to study shale, which is a sedimentary rock. You can see this rock is grey in color and poorly porous. Shale is made up of very fine particles, mainly clay and silt-sized grains, making the surface feel smooth. There are some key features that help us to identify shale in hand specimen, like its fissility. Shale has a characteristic fissile texture, meaning it breaks into thin flat layers or sheets along bedding planes, which help us to differentiate shale from other fine-grained rocks like siltstone or mudstone, which do not split as easily. Now let's study the structure of this rock. The sample exhibits laminated structure and the bedding plane are smooth and flat. The sample is composed of inorganic components, which is clay minerals and quartz. Clay minerals are identified by their grey color, earthy odor, and very fine sized particles, whereas quartz is identified by its grittiness. If we observe the texture of shale rock, we can see the rock is fragmental, grains are more or less uniform, and both silt and clay sized particles found in texture. Shale can vary in color based on its composition. It can be black or grey color, which indicate the presence of organic material, often associated with oil and gas reservoirs. Black shale can be rich in organic material and is significant in petroleum geology for its potential to generate hydrocarbons. Another special characteristics of shale is low permeability. Shale typically has very low permeability, making it an excellent cap rock in hydrocarbon reservoir. Shale is relatively soft and can often be scratched by a fingernail. However, it is more durable than clay or mudstone due to its compaction of fine particles. Shale typically has a dull to earthy luster and is not shiny unless the surface contains organic material or certain minerals that may reflect light. Especially black shales with organic material may emit a faint earthy odor similar to the smell of wet mud or clay. You can differentiate shale from similar rocks like siltstone and mudstone. For example, siltstone is slightly coarser grained than shale and may not break into thin sheets like shale. Another similar rock, mudstone, is also fine grained but lacks the fissility that shale exhibits. Mudstone tends to break into blocky fragments rather than thin layers. If we summarize the study, fragmental, silt and clay-sized texture and mineral composition suggests that this rock is a shale, which is a clastic sedimentary rock. We already studied the hand specimen of shale rock. Now let's observe the thin section of shale under the microscope. Here you can see both in PPL and XPL. Thin section of shale would display alternating light and dark layers corresponding to the variation in mineralogy and grain size. Here you can see there is alternating color, and the middle streak is built of silt-sized quartz and the other sides of this are clay. This is the plane polarized view, and this is the view of shale in thin section under the crossed polars. You can also observe alternating nature of clay, then silt-sized quartz. You can see the repetitive nature of clay and silt-sized quartz. By observing thin section of shale, you can say under the plane polarized light, you can see shale shows its fine grained nature, fissility with clay and quartz minerals. Dark spots represent organic or iron rich materials. Shale thin section under the cross polarized light shows that Birefringent minerals like quartz show the interference colors and clay minerals remain mostly dark. Now let's look at the thin section of shale under the plain polarized light again and observe its property, minerals, texture and structure. And here is the clear view of shale thin section under crossed polars. If you are struggling to identify quartz or mica or feldspar in hand specimen, please check out our latest videos where we studied the detailed characteristics of these minerals. I will give you the link of these videos in comment section or give cards here. In our next video, we are going to study another rock. That's all for today. See you in our next video.